All right, as you prepare for the final exam, I thought we'd do a little review. This is right from the online textbook, Beginning and Intermediate Algebra, and we'll start off with a Chapter 1 vocabulary check. Now, you might say, why is vocabulary important? Well, because it's the way we communicate. The textbook to you, questions that the teacher might ask of you or you might ask the teacher. And if we know the vocabulary, things go much smoother. So, here are the words: set, denominator, variable, inequality symbols, grouping symbols, equations, opposite, exponent, solution, absolute value, base, numerator, reciprocals. So, let's take a look. Number 1, the symbol does not equal, is less than, is greater than are called inequality symbols. A mathematical statement that two expressions are equal, that is, something on one side equals something on the other side, this is an equation. The what of a number is the distance between that number and 0 on the number line. Well, we said that was its absolute value. And since these were, in a sense, counting numbers, they're always positive. The symbol used to represent a number is called a variable. Two numbers that are the same distance from 0 but lie on opposite sides of 0 are called opposites. We also use the word additive inverse. That is, what you would add to something to make it 0. The number in a fraction above the fraction bar is called the numerator. What of an equation is a value for which the variable that makes the equation a true statement? That's the solution. Two numbers whose product are 1 are called reciprocals. In 2 to the third, the 2 is called the base, and 3 is called the exponent. The number in a fraction below the fraction bar is called the denominator. Parentheses and brackets and division bars and braces are example of grouping symbols, as is the radical sign, square root of something. What is a collection of objects? That's our first one up there, a set. Okay, so a little review of vocabulary. Now let's go on. We're going into what is called now the Chapter 1 highlights. Now, again, this is all in your textbook. You just have to go online to the end of the chapter, and all of this is there. So, just looking over again some of the words, some of the examples here. A set, as we just said, is a collection of objects. The members of the set are called the elements, and they are enclosed in braces. So these are the natural numbers. It starts with 1, 2, 3, 4, then an ellipsis that indicates this pattern is continuing. Then we have the whole numbers. We just add a 0 to it. Integers are the whole numbers on the right of the number line. Then to the left are their opposites. So these make up integers. Rational numbers are real numbers that can be expressed as a quotient of integers. And we had said that when you convert a fraction to a decimal, if the decimal terminates, like 1/2 is 0.5, or the decimal repeats, like 1/3 is 0.3, 3333, you put a repeating bar over it. These, plus all of these others, by the way, are the rational numbers. Now, irrational numbers are on the number line, but when we would convert the number to a decimal, it does not terminate like 0.5 or repeat like 0.333, but it kind of like bobs around. These would be the irrational numbers. And if you look over here, you see examples of all the things we've talked about. And then finally, all of the numbers on the number line are real numbers. So let's go on to the next page. So again, some good stuff here. There's the number line that is used to illustrate many of the sets we've just talked about. And we mention absolute values. And we put vertical bars on either side of what we're saying is an absolute value. And the absolute value of anything is always its positive value. And these are the symbols most often used in mathematics. And then we talked about order property of real numbers, that anything to the left of something on the number line is less than. Anything to the right is greater than. And here we talked about the typical quotient, which is another way to say a fraction. The upper part is the numerator, the bottom part the denominator. And we can sometimes put the dot between numbers or letters to indicate we're multiplying. So A times B, these would be factors that result in a product. So factors imply that you're probably going to multiply, and product is the result. All right, we talk about the lowest terms or simplest forms. That is, there are no factors other than the number and 1 in the numerator and denominator. Otherwise, you would need to take out those common factors. And reciprocals, we said, is what we multiply something by so that the product is 1. Now, when we multiply fractions, we look to see if we can cross-cancel common factors out. Otherwise, we just multiply our numerator and multiply our denominators. And if we couldn't cancel anything out over here, over there, there's nothing to cancel out. To divide fractions, we say we first convert the division of fractions to multiplication by changing the division sign to multiplication and then taking the reciprocal of the second term. Again, canceling out if you can, otherwise just multiplying across. Now, to add fractions with the same denominator, we just add the numerator, put it over the common denominator. And if you can simplify, you should do so. Subtracting is the very same. Notice here we have 10 over 15. Now we can take a 5 out of each one, and we end up with this. Now, when fractions don't have the same denominator, we must make equivalent denominators so that we can then add the numerators. But to keep it honest, so to speak, truthful and proper, we must have the same denominator to add and subtract. Multiplication doesn't require that. All right, continuing, as we move on, we're looking at the exponential notation, where, recall, 4 is the base, 3 is the exponent, and it indicates we're going to use that base 3 times, and we get 64. Here we're going to use the base twice and get 49. And the order of operations, you might recall, we had used the acronym. Please, let's see, I got a very thick pen there. Please excuse my dear Aunt Sally, where this was parentheses and exponents. From left to right, you would do those first. Then multiplication, division, whichever came first from left to right. If division came first, you would do that. If multiplication came first, you would do that. And the same thing with this, adding, subtracting. Okay, and they gave you various examples, and I'm sure you have tried numerous examples of this. All right, we talked about variables that are letters that stand for something, and we work them, and in an algebraic expression, we're just going to simplify. Where once we get to an equation, though, we are going to solve. And we'll go over that a little bit in Chapter 2. And when we do substitute or whatever we're doing, the results is our solution. Going on a little bit further, we talked about numbers that are opposite on the number line, or a synonym for that was an additive inverse. And here we have a -4 and a +4. That's 0. So it's basically a number, and its other number would be the opposite sign. And we have this special case over here where we have a negative preceding something inside the parenthesis, that here it's also negative. The opposite of a negative makes it a positive. And they gave us 2 examples here. And over here is the rule. The opposite of a negative is a positive. We can think of subtraction in this next item as A minus B, or we can think of it as addition of A plus a negative B. So subtraction and addition in algebra is very similar. And in fact, subtraction almost is done away with, but we do use it. The rule for subtraction, you may recall, is to change the sign of a number and then add it. Okay. The quotient of 2 real numbers, we can think of it as A divided by B, or the fraction A over B, in a sense is equal to A times 1 over B. Okay? And they give us some examples here. Now, another review that you may want to go over here is products and quotients involving 0. Anytime you times something by 0, the results is 0. Anytime you divide anything by 0, the results is undefined. We don't have a definition for that in our mathematical vocabulary. And anytime 0 is divided by a number other than 0, the results is 0. So notice the difference between these two. Very important. All right, as we start to look at some of the real properties, or the properties of real numbers, here are some friends. The commutative property, A plus B equals B plus A. Multiplication of the commutative property is A times B equals B times A, and they give you examples here. The associative property, the items are in the same order. We're just grouping them differently with our parentheses. Here are the first 2, here are the last 2. And this tells us that we could add the first 2 together, then the third. That would be the same as adding the last 2 together, then the first. And this is true of multiplication as well. You can do it in any order. All right, winding this up, I believe, we're going to go to the multiplicative inverse or reciprocals, that we say A, which is over 1, if we just flip it, we get 1 over A. And if we multiply a number by its reciprocal, another name for that is its multiplicative inverse, the product is always 1. Okay, and then we have the identity, or the distributive property first. We just distribute the A to the B, which becomes AB. Distribute the A to the C, a plus AC. Now, identities of addition is that you can add 0 to any number and the results are the same. And the identities of multiplication is you can multiply anything by 1 and the results are the same. And then inverses, the additive inverse or opposite, adding one to the other, you end up with a 0. And the multiplicative or reciprocal, multiplicative inverse is if you multiply something by its multiplicative inverse or reciprocal, the product is always 1. Now in the book, they do give lots of examples, and I believe we are offering you a little example sheet that we can work on in class or on your own that will help you prepare for your final exam. Okay, this is going to be about 20 minutes, which is perfect.